Hello, this is going to be the first of two videos running through the creation of a small application using WPF and TDD. I'm going to start by creating a WPF project, and it's going to be called Tiny Calculator. Should give a clue as to what this application is going to be. And alongside that, I'll create a unit test project, new project, test, unit test, and I'm going to call this Tiny Calculator Test. Okay, and I'll just add a reference from the test project to the Tiny Calculator project. Right, so what I'm going to start with is designing the basic UI. This will just help convey what this application is supposed to do. It's going to be very simple, just three controls. There's going to be a text box in which the user can enter a sum like 1 plus 1 or 2 plus 3. Nothing more complicated than that. And a button, so the user will press to perform the calculation of that sum. I'll put a title, caption even of calculate on the button, and then the final control will be a text block which will display the result. Let me just change the background of that so that it's actually visible. Background equals okay, so I'll just run this quickly just to explain a little more about what this application is going to do. Okay, so what I'm thinking is the user enters a sum like 2 plus 3, hits calculate, and down here it will just come out as 6. And it also supports subtract, so you could do 8 minus 4. Multiplies, you could do like 14 times 7, and divide. So it's 4 operators and only 2 operands, so only 2 numbers on each side of the operator. I'm not going to support stringing lots of operators together. Just to keep it simple and short, it's going to take long enough just to do this little bit. So I'm going to start by creating a test, because this is going to be test-driven development. Let me just rename these tests to calculator test. This test to calculator test. Just give it a better name. And I'm going to first of all just write a test that I can instantiate a calculator, and this test will effectively drive the creation of a calculator class that will be used to perform calculations. Because as soon as I've written this test, it doesn't compile. So in order to get it to compile, I'm going to create that class in the other project, of course. So the calculator class, and it's been created. So let me just run that, compile and run everything. So what that's done by writing that test is it's started off immediately, got me developing part of the application. The initial part is just to create this calculator class. It's taken a bit of time to pick up the test, so I'm just going to continue on and write the next test. The next test, I'm going to test 1 plus 1. 1 plus 1. I'm just going to keep the test names fairly short, just for time here. Calc equals new calculator, and what I want to be able to do is say I want to be able to return a result from a calculate method on calculator. I'm going to pass in the 1 plus 1 as a string parameter, and what I expect from this test, I expect that result, the expected result should be 2. So the calculator should return that 1 plus 1 equals 2. So it's my test. It won't compile, there's an error, and the error is because there's that calculate method doesn't exist. So that's as simple as right click, generate. generate that method. So this will compile now, but let's see, when I run this test, what will happen. See that other test did pass, can instantiate calculator. And we've got, 1 plus 1 has failed. And why is it failed? It's failed because of a not implemented exception. And that's because while I created the method, I haven't actually written any implementation for it. So it's just left with this throw not implemented exception. Let me just tidy this up a bit and make the parameter name a bit more sensible. And the trick with TDD is to do the minimum effort to get the tests to pass. And in this case, the minimum effort is actually, will look a bit strange, but it's return 2. That will get this test to pass. And it might look on first sight that that's a crazy thing to write, because that's clearly not going to be how a calculator works. You know, passing a sum, it always returns 2, but this is test-driven development, so we're not getting ahead with the development, too far ahead with the development. It's always write tests. If I want this to be improved, the way to improve it, get closer to the required functionality, is to just keep writing tests. So the next test I'm going to write is, I'm actually going to write a test for invalid inputs here, because I've noticed that, so let's just call this test invalid inputs. I've noticed that you could actually here pass in complete gibberish, like just A, B, C, D, E, so not a sum at all. And then the question is, what should it do in that case? And what I'm going to do as part of the requirements is say that if you type in nonsense like this, it obviously can't return a result because it's only got an int result, and that's always going to make all range of impossible integers return are going to be used. So I'm just going to expect that an exception is thrown. So I expect that calculate method to throw an exception. So what I'm going to do is I'm going to catch the expected exception. Let's just say invalid operation exception. Oops, invalid operation exceptions fits, rather than creating a new exception. Invalid operation exception. So I'm going to catch that, and if that's not caught, then I'm just going to do assert.fail. So that fail will go off if this exception does not occur on that running that calculate method. So let me just run that now, and that fails, and that will then, in order to fix this, I've got to go into the calculator method and figure out a way of getting the test to pass, and hopefully keeping the existing tests passing. So what I'm going to do here is I'm actually going to change this and say if the input equals 1 plus 1, return 2. And if not, I'm going to throw new invalid operation exception. And if I just run that, hopefully that will pass. And you see what's going to happen here, that any other sum now is going to return invalid operation exception. So that isn't how isn't how a calculator will work. But to improve things, just write more tests. So the next test is going to be, I think, 2 plus 2. Let's do 2 plus 2. So I'm going to start writing more, just more sums. 2 plus 2, and that should equal 4. So if we run that, that's failed. So what's the minimum effort required to get this test to pass? Well, I could just add another condition here for 2 plus 2, and return, in that case, return 4, and that will get the test to pass. Hooray! So let's write another test. Let's do 4 plus 7. That will there's a little different as well, because there's 2 numbers on the right hand side. Sorry, the result. No, let's make it 2 numbers. So I'll do 4 plus 11, and that should come out as 15. Let's run that. Of course, that will fail. And so we've got to go in and fix this. It's 4 plus 11, isn't it? And you can see that, okay, we could implement a calculator by just handling every single possible input. Um, it would be a very long method. Well, it'd be extremely long. But alternatively, at this point, you can see there's a pattern here, which generally means it's a good time to refactor and to refactor out all of the common pattern and put it into more sort of more abstract form. So, what's the pattern here? Well, the pattern is that we're taking the left-hand side number and the right-hand side number, and the thing we return is those two things added together. So let's split on that plus symbol. So let's do let's split the input string on a plus symbol. Make sure I've got this right. Okay, so that will split, that will produce for each of these three, that will produce two parts, the left-hand part and the right-hand part. So I'm going to say int left equals part 0. Oh, I need to convert that to an integer. And the right-hand side will be parts 1. And then I should just be able to go return left plus right and nuke all of that. What's happening here? Let's just delete that and see what happens. The good thing about having all the tests already been written is they will catch any. They're very good for the refactoring, so they will catch any mistakes made in refactoring. And look, there has been a problem. Test invalid input no longer works. Well, yes, because the expected invalid operation exception is no longer being raised. So how to fix that test while keeping all the other tests passing? And straightforward way is just to say, well, if the input contains plus character, then we do the splitting on the plus character. If it doesn't, we just throw the invalid operation exception, and that should now pass all the tests. Okay, yep, cool. And as a result of doing that, I won't write any more plus tests just to save time, but in fact all of the plus operations are now covered because of that refactoring. So that case will cover all plus operators. So what's the next step? Let's do a minus operator. Let's write a test for that and drive the development of that. So let's do 2 minus 1. Test 2 minus 1, 2 minus 1. Maybe should have put test prefix on all these methods, but I'm trying to keep things a bit short here. Okay, so 2 minus 1 should equal 1. Of course, we already know that's not going to work because I'm not doing any handling for minus. So now, in order to get this work with a minimum change, well, the minimum I can get it to work with, I can just say if input equals 2 minus 1, return 1, and that will pass it. Okay, cool. And now continue. Let's just quickly create one more minus test. Let's do something like 46 minus. No, I'm not going to do that because it's going to take too long to type the method name. 5 minus 2 will be quite quick. 5 minus 2, and expect that to equal 3. So run all the tests again. It's the same story. That one will fail, and we come in here. We've now got to handle 5 minus 2. And if I did put that in, we'd start noticing the same pattern that we saw with plus. So there's time for another refactor to refactor out the subtraction ones, and we can see that we can just copy what we did for the plus. We can just copy that exactly and just put a minus in, replace these with minuses, replace that with minuses, and if we now run the tests to make sure that fixed things. Okay, cool, it did. Now, before actually continuing with writing more tests, I've noticed that in here there's now a pattern going on in the tests themselves. Each one of these tests is it's 3 lines, and there's a lot of duplication going on between them. The only unique parts of each test are these 2 parameters here. So this can be split out. It can be parameterized into like a separate method. So if I do, let's just call it like do sum test. I have a method called do sum test, and those 2 parameters are string input and int expected. I'll say just call it expected rather than expected result. If I just copy paste this code in here, and I'm just going to parameterize these, so that will be input, this will be expected, and what that means is I can now replace all of this with 2 plus 2 expected 4. So I can replace that with 1 line of code. I could do it in turn of each one of these. So this one will be 4 plus 11, and not only is this reducing the amount of code, but it's also by removing the redundancy, there's only one copy of one place where all this is done. So if I do need to change that later, there's only one place. You can see the problem of having to change it in multiple places, which is what I'm having to do now. I've got to replace all of these methods with a single line. If I'd refactored, imagine if I didn't refactor and I'd done a whole load more tests using the same pattern, like maybe like 30 more tests, testing minus division, and then I decide to refactor. I'd have to go down and change all of these methods. It would be quite time consuming. So keep refactoring every time a pattern is seen is really useful. Oops, I almost typed that test wrong. Yeah, the danger here is to actually create an invalid test and it just passes. For example, if I accidentally copy pasted 1 plus 1 2 here, it would pass, but it wouldn't actually be testing what the method says. So that is one danger of doing a lot of copy paste refactoring. I've just checked those. They will pass. So next step is, and I'm going to do this part reasonably quickly. I'm basically going to refactor the method of doing this video. So I'm going to do the next part a little bit quickly because we're going to move on to time. So I'm going to do 5 times 2. So I'm only actually going to write 1 test for this because I think the pattern's quite obvious from thing. We know that's going to fail. Now in here, eventually I could have lots of multiply tests and we'd do the same thing. We'd see the pattern and we'd create another one of these blocks, and now we see another pattern emerging, like a sort of higher level pattern. We've now got a pattern of these blocks. It's like, oh okay, so what they got in common? Well, each one of them has got the same operator here, and it's the same symbol for the operator and the operator itself. There's only 3 parts that are kind of unique in each block. The other thing about it is that these things are run sequentially. There's an if, and an if, and if you go into 1, it's just going to return. So this is like calling for some sort of for loop to loop over the operator. So we're going to first want to go through test asterisk, then test minus, then test plus. So what are we going to be iterating over? Well, the operator's symbols. Let's do the operator symbols. Let's create like an operator's array, and each element of this array is one of those symbols. So let's just put the minus in and the plus, like that. So that's our array, and then our for loop, I'm actually going to just do for each char O. I'll actually use just var O. In operators, for each of those, and just copy this block, and then just say if the input contains that operator, then split on that operator. And this bit's a bit tricky because that's a char, and somehow we need to go from the char to the actual operator, the actual C# operator, and there's obviously no way in the language to actually just convert a string to an operator. So So what I'm going to do is here, just to get everything working, I don't want to do too many changes at once, is just do a quick test, just do a conditional test for each operator. So if it's a plus, then I will turn left plus right. If it's minus, then I'll do minus, and if it's multiply, then I'll do multiply. So let's get rid of that. It's a whole load of code removed. Well, it's almost the same length, but it's just like kind of a bit purer because, again, there's not duplication. So if I need to change one of these things like string split, I might decide that I need to add the string split options, remove empty entries, which is always not a bad thing to add. And I've only had to do it in one place, whereas if I had, 3 of those down there, or 4 if I had division as well, I'd have to be doing that in multiple places, and you can easily forget to do it in one of them, and that will introduce a bug where you've got different behavior with different operators. So let's just run that. Hopefully it all passes. Cool, it does. And now I'm going to do the final part of this piece of development, which is the division. So I'm going to do 8 divided by 2, 8 divided by 2 as a test. That will of course fail. 8 divided by 2, and now the simple way to do this, and makes the refactoring just done, has made this quite a lot easier, is, whoops, that's not the right symbol. Okay, it's just a very small amount of changes here, and run that, and it should work. Okay, cool. And final thing I'm going to do is I'm going to actually refactor this part, because this part's just sticking out like a sore thumb. Even though to refactor this I'm going to actually end up creating more code, it's just going to be in like a nicer solution. The thing that all of these have in common is that they're all actually a function taking 2 parameters, two integer parameters. They apply a different operator, but they're the same function, two integer parameters, and they return an int. So what I'm going to do is actually create an operator class, because what an operator has got is it's got 2 things. It's got a symbol, a character symbol, and it's got a function. So I'm going to create a class called operator. I would put this in a separate file, keep it separate, but this is just going to be a bit quicker just doing it like this. I'm going to create a constructor called, I realise this part isn't particularly test driven, but this is just a quick refactor, so I'm not sure whether I would write a test for operator, because it basically is just going to encapsulate 2 fields. Okay, so char symbol, that's going to be the symbol, and then the other one is going to be a func int. So that's basically a function that takes 2 integer parameters in, and it returns an integer parameter out. And I'm just going to call that its function. So let me just create backing fields for these things. Actually, I'm going to just to save time again, I'm going to make them public fields rather than properties. Public, copy paste this, don't want to type it again. Okay, so now I just need to set these in the constructor, symbol, and function equals function, like that. And now what I'm going to do is I'm going to replace this array, is now going to be not an array of char, but an array of operators. This part's going to be a little dicey because I've got to effectively create the elements here. So there's going to be 4 operators, new operator, plus, and I need to create an anonymous method here. So what is it going to be? Left, left, right. Those are the input parameters, and it's going to return left plus right. I don't think that's the right syntax. Might need a bracket, curly bracket. Yeah, the only thing I don't like about anonymous methods is they do make the code look a little crazy. But this is just a quick thing to do at the end of this video. So left minus right. So you see now I've created 4 operators. Each one of them has a symbol, and each one of them has its own function. So what I do down here now, the reason why I used var earlier actually, because I knew I was going to be replacing this, so that just works. And now I say input.contains operator.symbol, so that's the operator's symbol character, and I split on that character. And what this allows me to do down here is I can now use the operator's function, which takes 2 parameters, left and right, and I can just return that. And that's actually made this a lot more concise. Like I said, it's actually created more code, but I think it's like structured more nicely. You've got like the actual operators. It's not liking that. Maybe it needs a semicolon. Let me just test that by just building it all. Everything's like a bit more nicely encapsulated. You've got like operators have got symbols and their function. You could potentially add more stuff. I think like really this was asking for operator to be have its own class. I'm not sure how easy this will be to extend if you were to try and support, say, multiple operands. I've got a feeling it's good. In a way, the refactoring of this has made it very specific to 2 operands and 1 operator too. I mean, if I created a test with different operators in the same sum, that's probably going to be just adding that test would probably be more work to get this test to pass and these ones than all the work done so far. And that might be finds that the refactoring has made it too specific and you almost have to go backwards, back out, and come back in again. So in a way, I mean, it might be interesting to actually say, okay, I've gone too specific. I'm actually going to revert the code to where it was, say, 20 minutes ago, when maybe I only had 2 addition tests, and I'm actually going to start from there, and I'm actually going to try and start the TDD off again from there, and see whether approaching it from that angle will produce. It will produce obviously different code, but whether you could actually get everything working. So I think probably this was a good thing to get, well, at least maybe this was a good thing to get working right at the start, if that was the requirements. Anyway, that's the end of the video. In the next part, I'm going to be taking this, which is effectively the model that I'm going to use, and getting this working, creating a WPF front end for this, so that this actually displays in a little desktop application. I've actually designed it. I just forgot that I've designed this. It's basically going to involve wiring this up, and that's going to be test driven as well, because there's a whole bunch of glue code that has to be added and can be tested. So thanks for watching this video. Goodbye.